Welcome to BONZAI Podcast. I'm Karyna, your host today. Today, we are going to discuss the latest trends in NLP for intelligent document processing. My guest is Eduards Mukans, machine learning architect at Graip.ai. He makes contribution to NLP through his blog and has also published several works in forum like the Association for Computational Linguistics ACL. Eduard, before we start, I'd like to know a bit more about you, your experience, your career path, your hobbies.
Hello, thank you for inviting me to the podcast. As you mentioned, I'm the new machine learning architect at Graip.ai. I've recently joined, and I'm also contributing to NLP through my blog. So you could find me in the Telegram application. You could search for deep learning for NLP. Or I'm also publishing some blog posts on LinkedIn for now. And yeah, unfortunately, I'm not doing that on the regular basis, but soon I will introduce a new deep learning course, like from scratch. So you could stay tuned and following me. Regarding my experience, I started as a developer around 10 years ago, and around 5 years ago, I've started working in NLP field, and yeah, recently joined Grape AI. And today I will introduce you the recent trends in NLP for intelligent document processing.
Great to know about the resources that you mentioned. And for our audience, we will add it to podcast description so that you can access and read more about Eduard's knowledge and his upcoming course. And now let's move to the main points of our discussion. Can you please explain in simple terms what NLP is and how it works?
Well, the computers are not like humans. They do not understand our language, so they communicate using numbers and bytes. So the NLP is kind of a technique for translating our human language into the computer language, so into the numbers and bytes. And by using these techniques, um, that's the same as using the Google Translate for humans. Then you could use the NLP for translating into the computer language.
It's good that you mentioned here that computers, they are not communicating as the humans are. So I'm trying to figure out how exactly they differentiate one word from another.
As I mentioned before, NLP gives us ability to translate our human language to computer language, and then these words are represented in the vector space as plain numbers. So you could perform any mathematical operations on top of them. For instance, you could perform something like a king minus man plus woman equals. So you might guess what it will be.
Queen?
Yes. And yeah, these techniques are the classic ones. One of the first ones, the ones what were described and known as word-to-vec. But the recent trends uses the context-aware um, notation, and the latest architectures like transformers use these context-aware embeddings.
Wow, interesting. You mentioned transformers. I started to think about Optimus Prime, but of course we are here not to talk about the movie. So, talking about of recent trends in NLP, can you explain the concept of transformers and how they can be used in intelligent document processing?
Yeah, sure. As I've mentioned, they're using the context-aware embeddings as their base. So this is known as an attention mechanism. So, for instance, I think you will agree with me if I will say that if I just say the king, it gives us some information. But if I say a cruel king or a kind king, that would give you some extra information, some extra context. What I would like to say. So the attention mechanism is basically the way of scoring the relations between the words. So if we see a cruel king, then some did some action, then we will know that the cruel will relate to the king with the higher score than some other word. And then this will give us some context that this word is related to the another word, and it's important. So this is known as an attention mechanism. It's the base of the transformers, and yeah, the transformer architecture. It's basically a sequence-to-sequence architecture. So as input, we receive a sequence, and then as output, we are generating another sequence. And this is known as an encoder-decoder architecture. And the main key feature of the transformers is this attention mechanism.
Okay, interesting. About attention mechanism, for me, it seems the same way like when two people communicate with each other and know about previous experience, background, it's better to find a common context and sense and understand better the questions that people ask to each other. So this attention mechanism, it's kind of mechanism for communication between us and these models. So you also mentioned here encoder and decoder. For us to better understand it, maybe we can talk a bit more about BERT and GPT. In terms of architecture, decoder and encoder, who are who?
Yes, uh, both models that you've mentioned, the GPT or generative pre-training or BERT, they are using just half of the transformers. So the BERT is the encoder, and the GPT, that's the decoder. So it means that BERT receives the sequence, and then it reads the full sequence. That's why it has this B in the name. That means that bidirectional, meaning it reads the full sequence at once. And then it represents this sequence in the vector space using this attention mechanism that I've mentioned before. The same operations like with the king and the cruel king and etc. So it's a context-aware embedding or representation. And then these context-aware word representations or sequence representation could be utilized in some downstream tasks like classification or yeah, sentiment analysis, or maybe some extracting some information like named entity recognition or whatever. So the another model is GPT that uses only the decoder, and it's a generative model. It meaning it generates a token per token. The BERT is generating the whole sequence at once, and that's the difference between the encoder and the decoder. And yeah, the recent popular models by OpenAI, like GPT-1, 2, 3, 4, and plus many others kinds of the GPT, including the Chat GPT, utilizes the same generative approach. So they receive some sequence encodes that using the attention, using these context-aware embeddings, and then they are generating the output. So that's the main difference between the encoder and the decoder.
So, GPT is the coder, it's clear. And now, considering all the trending about ChatGPT, we probably heard about large language models. So, what are LLMs and how do they differ from traditional machine learning models?
The key difference is the number of the parameters. Because of the modern size of the models are now counting on the billions of the parameters, that's gives us an ability to encode the vast of the human language relations and the aspect of the language. And this also gives the ability to computers to more deeply understand the human language. What is the most statistically probable output if the input is the following. This gives us an ability to use some prompting mechanisms like few-shot learning or zero-shot learning, and etc.
Hold on a second. And what does it mean, few shot and zero shot?
Yeah, the few-shot and zero-shot learning and the prompting mechanisms in general, that's the ability of the computers to understand the given commands. For instance, we could give a prompt like translate from one language to another language, and then some sentence, and then the computer will understand will understand the command itself. In this case, for instance, translate from English to French, and then the input. So since these large language models know the human language, they know that the most probable after this prompt will be some sentence in the French language, and it will keep this input in the memory by using these context-aware embeddings, and will produce some relevant translation. This could be also applicable not only for translating, but for other business use cases, maybe for extracting the data or classifying and etc.
Wow, let's try to imagine some examples of business use cases. I think it will be beneficial for our audience as well. I will try, and please correct me if I'm wrong without something, but for me, it seems that one of use cases that can be used in enterprises is back and forth communication with the customers. Sales department, by receiving requests for quotes, RFQ, can have some questions to clarify information, or maybe some information is missing in the document or in the email body, and usually they write a follow-up email. Seems that GPT models, they can, by using this few shot and zero shot mechanism, predict, understand what to ask, and they will generate this template of email, follow-up email to clarify the questions instead of the sales representatives. By this, they will, of course, save time. And I guess this way can be one of business use case. What do you think?
Yeah, the main benefit of this zero shot and the few shot is that we just need just a few examples in order to produce some value. The classic theory says that we need some huge data set in order to train some statistical model, but by utilizing these large language models, we already utilizing some the human language relations that are encoded in the model, and it already knows something. It maybe won't be very accurate in some tricky cases, but in most of the cases it will be correct. So, for instance, you could produce him an example of input and then an example of output. So, what you would expect. This will be a prompt. So then you append some another input, but you do not provide the output. What to expect? So this would mean that this model need to generate this output, and in this case we provided some template for that model, and then the model understood us and generated the appropriate output.
Mhm. Okay, understood. And you mentioned here about the mechanism of retraining of this model, that you need to provide, first of all, example of request and response. And next time when you will provide additional request, machine will provide response in a way with a context, in a structure, as it was in a previous response, right?
When you're using this prompt engineering, you are not touching the weights that are encoded in this model. So it won't affect the model itself. Um, so every time the model won't know about the previous request. So in this case, you will need to provide some examples again and again when you are start using it. Of course, you could fine tune on your use cases and then avoid these examples, but this will be the full fine tuning, and this would require much more data and much more examples than the regular few shot learning. Or by the way, if you're using the zero shot learning, it means that you are not providing the examples at all. You just need to provide an appropriate command. So for translating case, it would be translate from A to B. Uh, it could be any other application. So, for instance, if you could write something like extract all the named entities from the text, but since the language model doesn't know what exact named entity you are interested in, it will extract maybe some incorrect information or too much information or not enough information. For instance, it would extract the name, but you was interested in some product name. So it won't know that. For that, you would need to provide some examples, like use the few-shot learning or the model fine-tuning. But yeah, I've provided you some examples for translating or extracting the information. Maybe you could also imagine some other business cases on top of that.
I can imagine use case in enterprises when on email, user can receive different emails with different context, with different information. Like, for example, back to sales department, they can get request for quotes, they can get some complaints in email with the claims, and they can receive information ready to be sales order in the third-party system, like purchase orders. And for claims, they will definitely start with something like we notified this issue with a quantity or with a quality. This is one type of context. And if it will be RFQ, request for quote, probably there will be some context about can you please provide the best price, or can you please provide available in your stock number of this product. So I assume that by knowing what exact context expected from the claims types of email and RFQ types of email, large language model can help us to classify these documents in different folders, flows inside of IDP solutions.
Yes, you are right. So for large language models, it would mean like it receives some sentence, your input, and then it receives a task. For instance, classify in the following categories, like RFQ, claim, or purchase order, or whatever, and then the input. So the large language models will understand, will represent this input in some vector space, and it will represent these categories in the vector space, and we'll try to match what are the closest, something like that. So of course, it happens not like that. It not splits into separates. It just understands the whole context, but that's more like um, the idea how you could explain these mechanisms. So in your case, for classification, it the zero shot prompt could be something like classify the text into the categories RFQ or request for quote, claim, or purchase order, and then the following the input. Yeah, so something like that.
Okay, you explained it better how to pack this information into zero shot and what response we can get from it. All right, so we discussed already points about text recognition, and I heard that for GPT-4 model, it will be possible to read information from images. And by this, we are coming to idea about multimodality. What are your thoughts on this trend?
Using the modalities is the way how to get another representations of our human life. So we kind of try to teach computers how how do we see the life as a humans. So the text, it's the one modality, that's the one world. The images, that's the another one. How do we see that? So you could imagine that the blind people see the world differently, but the same the computers imagine if you have the text only language model, it would be the same as seeing or similar to seeing the world as a blind. So just reading and that's it, but not knowing how it exactly looks like. For the modalities, you encoding the same or similar information in other formats, the language model will know the shapes, how this looks like. So imagine you have read a sentence about the new color. Can you imagine that color without seeing it? I believe no. That's the same as for language models. So if we are providing the another modality, it gives some extra context to the model, and we could utilize or combine our existing data more, since the quality of the data, that's the very important question. Um, and um, Creating these large data sets, that's very costly. So we need to find a way how to utilize the existing data sets even more. So the multimodality, that's one of the way how to improve the ability of understanding our human world, and how to explain that to the language model.
So it's basically allowing to have additional source of the data that will increase accuracy of understanding the context of our requests to get better response from these models. And how can we use these large language models from OpenAI in our landscape via connection with intelligent document processing solutions, for example? I heard that they provide APIs, and by this you can provide some information to them and get some information back. But question is about how to maintain data privacy in such communications.
Yeah, the data privacy is a very important question nowadays. We have heard a lot of the data leakages that happens like on the daily basis. Even OpenAI has own issues. I have heard about the case. I think in the beginning of this year, that the chat GPT users were able to see some other person information, like email, personal name, even some part of the credit card number. The data privacy is very important, not even take into account these giant companies like OpenAI or Google and Azure and etc. So if we are utilizing these large language models using the API, the best way to secure our data is not provide any sensitive data in this API. So the first step would be anonymizing the input, so removing the personal information or some sensitive information, and this anonymization depends on every case. It should be handled separately. Like if you're processing some card data, most probably you will need to anonymize these vehicle numbers or VIN numbers or whatever information. If you're processing some health data, then that's the personal number or the personal name, maybe email, and maybe some part of the health status should be anonymized. So by anonymization, I'm saying that if you're using these prompting mechanisms, you are providing some text. And instead of providing something like, hello, my name is Eduards Mukans, I'm contacting you to receive a quote for these items, you would replace something like, hello, my name is, or just hello, I'm name, and then I would like to receive a quote for these items. And this would count as anonymized email, and even if this information will leak, uh, just because of the third party provider like OpenAI or Azure, the client information wouldn't appear. So by anonymizing the prompts before sending anywhere, it still won't protect you from the data leakages by the third party, by the third party, but um, you have to accept this risk if you want to use these capabilities of the large language models, and this will make you safe against data leakages.
Of course, personal data privacy is very important, but it would be nice if also these solutions will provide functionality of automatic anonymization of sensitive data. And I know they did a lot for this, especially if we heard about case that Italy tried to ban ChatGPT due to their data privacy, and then they solved this issue. And I know that there is still a lot of work on it, on how exactly protect our data, but there are some upcoming regulations in place. They will come, and probably they will help us to be more secure in environment of GPT models. By this, I would like to thank you, Eduard, for being with us today. It was interesting and insightful to understand the structure of transformers, their architecture, how do they work, on a couple of business use case scenarios to understand how they can be beneficial for business. And thank you for listening, and see you in the next episodes. And don't forget to subscribe, just to make sure you don't miss them.
Thank you.